Howdy, PreCal. It is Miss Kosh. We are looking at 1C is how we've broken this down, graphs of functions today. So this page right here is basically filled out for you, but I want to talk through them. These are the parent functions that you learned in Algebra 2 that don't go away. We still need to know them for PreCal. We need to know them for calculus. This is just the foundation of algebra that plays out the rest of our mathematical career. Okay, so the first one is a linear function. Maybe I'll make this a little bigger because it's kind of small type. The linear function y equals x is the parent function. It is, when we have an x equals 1, we have a y equals 1, x equals 7, y equals 7, and so forth. And so notice on this one, if I do f of negative x, it would equal, so this is saying our original function, f of x, was just equal to x. I'm sorry, you can't see that on top of the black lines. So f of negative x, we talked about how to find out if a function's even or odd. Well, I would just plug in negative x where I saw the x, and this is equal to, well, if x is f of x, this is just a negative f of x. And since we showed that f of negative x equals negative f of x, that tells us this type of function is odd, which means it has symmetry over the origin. Anything I have in quadrant 1 rotates down into quadrant 3. If it had been in quadrant 4, it would rotate to 2, but we don't have anything there. Okay, the domain is all reals, negative infinity to positive infinity. The range is all reals, negative infinity to positive infinity. There are no restrictions as to what we can do. We can plug in any real number for x that we want, and we will get the corresponding real number for y. So the end behavior, as x goes to negative infinity, as x goes this way, y goes to negative infinity. So we're going negative, negative, and it follows this path here. As x goes to infinity, y goes to infinity. So as x goes to infinity, y goes to infinity, and so we're increasing like that. Okay, the next one is the absolute value function. Okay, so if we say f of x is equal to the absolute value of x, then f of negative x would be equal to the absolute value of negative x. Well, if you could think of this as saying it's the absolute value of negative 1 times the absolute value of x. The absolute value of negative 1 is positive 1. And so this is equal to the absolute value of x, and I just ran out of space. But the absolute value of x is where we started. This was f of x. And so we just showed that f of negative x equals f of x, telling us that therefore this function is even. Okay? And so what this does is it takes the piece, so here's the same line that we had a second ago. See how that's exactly the same? But now where it was negative, we now end up with a positive. When I have a negative input, I now have a positive output. So this line right here kind of reflected back, and then kind of, it did reflect back up here. You could think about it, okay, if I do if I plug in f of negative 2, f of negative 2 would be equal to the absolute value of negative 2, which is positive 2. And so at negative 2, we went up here to positive 2. Okay, so this domain, we can plug in anything we want forever. Any real number is good, so negative infinity to positive infinity. But we're only going to get positive numbers or 0. You do know that 0 is neither positive nor negative, but the absolute value of 0 is 0, so we include that. So it's got that hard bracket, is how I say that, on 0, and it goes to positive infinity. The end behavior, as x goes to either negative infinity or positive infinity, so either direction, the y value is going to positive infinity. So as x goes to negative infinity, y goes to positive infinity. As x goes to positive infinity, y goes to positive infinity. And it's an even function, so it's got symmetry over that y-axis. Okay, the quadratic is the next one. It's also even. You can see how if we reflected it over the y-axis, it would match up exactly. The points that we want to consider are 0, 0. You go over 1 and up 1 in either direction. So if I take a negative 1 and I square it, be careful with your calculator. If you type in negative 1 squared, your calculator will say, oh, square 1, get an answer, make it negative. What we want to say here is this is a negative 1 that we are squaring. So this is a negative times a negative, which becomes a positive. We also want to look, we've got the point 2, 1, 2, 3, 4, and negative 2, 4. So those 5 points are kind of the foundation of our quadratic. Its domain is all reals. We can plug any real number in and square it. But our range is going to go from 0, we're going to include 0, so notice I've got those hard brackets here, to positive infinity. Okay. In behavior, it's similar to the absolute value. As our x value either goes to positive infinity or negative infinity, either direction, our y values are going up to positive infinity. Okay, the radical, now what happens here, we're going to talk more about this, becomes this, the square root is the inverse of the square, and don't worry, we're going to talk a little bit more about that, but it undoes the square to get to take the square. Anyway, this one, if I tried to have the second part to match like this guy entirely, it wouldn't be a function anymore. So the square root, if I say, we have the point 0, 0, we have the point 1, 1, the square root of 1 is 1. The square root of 4, 1, 2, 3, 4 is 2. And so those are the 3 points that I would start with. So I went, and the next one, I'm going to plug in, well, so what did I say? I said 1, I said 0, the square root of 0 is 0, I squared this, the square root of 1 is 1, the square root of 4 is 2. What's the next perfect square? The next perfect square is 9, and its square root is 3. So then I would have 9, 3 over here. Okay, so my domain, I can't take the square root of a negative. If I try to, I leave the real world, and we're only graphing real x values and real y values. So if I tried to say something like the square root of negative 1, it does have a mathematical answer, it's value I, but there, in our x-axis and in our y-axis, we are graphing real numbers. Oh, did I show you the right one? Okay, so the domain and the range are both 0 to infinity. And so on this one, as x goes to infinity, y will also go to infinity. X can't go to negative infinity, so we don't need to write that. Okay, and this is neither even nor odd. Notice there's no symmetry. I didn't take this from quadrant 1 and reflect it down into quadrant 3. I didn't have this also from quadrant 1 into quadrant 2. I didn't fold it that way. So it is neither even nor odd. Okay, so the cubic, if I look at this one, I can, let's make a little table of values. If I have x and then I have the x cubed, let's say negative 2, negative 1, 0, 1, and 2. I'm sorry, I ran out of space. Negative 2 cubed means I have a negative times a negative times a negative. I had 3 negatives. Well, 2 of them make it positive. 1 more makes it a negative. This is, and 2 times 2 is 4 times 2 is 8. So this is a negative 8. Negative, negative, negative 1 gives me a negative 1. 0 cubed is 0, 1 cubed is 1, and 2 cubed is 8. Okay, and so notice on this one, I've got 0, 0, I've got 1, 1, and I've got 2, 8. My eyes are not good enough anymore. Don't get old, I don't recommend it. No, I'm just kidding. And that's kind of the parent function that we look at there. So we can cube anything, any real number, and then we're gonna get any real number because cubing a negative keeps it negative. In behavior, as we go to negative infinity with x, our y goes to negative infinity. As we go to positive infinity with x, our y goes to positive infinity. Okay, now the cube root is the inverse of the cube. But what happens here, we've got 1, 1, that's 0, 0. We've got 1, 1, and now we have a positive 8. Is that here? Positive 2, I think so. Pretend, let's go with that. Because the cube root of 8 is equal to 2. Oh, you didn't see what I was writing. And the cube root of negative 8, its real answer is equal to negative 2. Did you know it has 2 more answers, but they're non-real, so we're going to ignore that. Okay, so negative 8, when I have an input value of negative 8, I have an output value of negative 2. And negative 1 right here. Okay, so my end behavior as x goes to negative infinity, y goes to negative infinity. As x goes to positive infinity, y goes to positive infinity. The next parent function, we're going to do a whole unit on exponential, but this is y equals b to the x, or b is bigger than 1. Okay, so this becomes an exponential. I'm going to write the word growth because they've indicated that b has to be bigger than 1. And so our domain, I can make an exponent of with any number I want. I can take 2 and raise it to the, if I take 2 and raise it to the 10th power, this is, well, I like to do 2s on my fingers. 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. Do you know how I'm so good at that? I'm really good at that because I like the game 2048. Have you ever played 2048 on your phone? It's really fun. But I can also say 1 over, I can also say 2 to the negative 10, which would be equal to 1 over 2 to the 10, which would be 1 over 1024. So it's a pretty small number. I have $1 that I'm sharing with over 1,000 people. You don't get much, but it is a number and it does give us an answer. Keep in mind, if I took 2 and I raised it to a ridiculously large negative number, this becomes 1 over 2 to that ridiculously, I don't even know how many zeros, I'm not going to count them. Sorry. But this, it's like saying, I'm going to donate, I'm going to be so generous and give $1 to the whole wide world. You just have to split it. So you have 1/7 billionth of a dollar. You're like, well, it's not zero, but it really might as well be. Okay, so that's why our range, it has a soft bracket on 0. It'll never hit 0, but it gets infinitely closer. It gets closer and closer and closer to 0 as we go. Okay, so as x goes to negative infinity this way, it gets closer and closer. This, by the way, is the asymptote. We have an asymptote at y equals 0. As x goes to infinity, y goes to infinity. Okay, the logs, which we're going to talk about more, look something like this. We switch, exponents and logs are inverses of each other. So we're going to spend more time on this, I promise. But it's going to have a domain of, the domain of the log is the same as the range of the exponent. Okay, and so it's going to have a range of all real, but a domain just of 0 to infinity with soft brackets. And so our end behavior as x goes to 0 from this plus sign tells us 0 from the right, it's going to go down to negative infinity. And as it goes to infinity, as x goes to infinity, y goes to infinity. Okay, rational, I don't want to call them inverse. Oh, it's an inversely proportional relationship. That's why they said that. It's not the sometimes we'll see situations where we're like, such and such varies directly as such and such, and then they'll say such and such varies inversely as such and such. When they vary inversely, it ends up being rational, but let's just call this a rational function and move on with our lives. The parent function, you'll notice, is odd. We've got stuff in quadrant 1 that also happens down here in quadrant 3. It was reflected into, around the origin into quadrant 3. And so the domain, if you remember, okay, so here's our function, f of x equals 1 over x. You are not Chuck Norris. You cannot divide by 0. And so we cannot let x equal 0. So my domain is going to be everything except that. Okay, and then you'll also notice, so that's the domain, it's going to go from negative infinity to 0, soft bracket, pick it up again, 0 to infinity. We also find that, oh wow, the paper last 2 years ago used to not bleed through. If I take, what do I want to say? Say I have x plus 1 over x plus 2, and I want to see when does this equal to 0. Well, what happens here is I want to make the numerator, if I get the numerator equal to 0, it doesn't matter what it matters as long as the denominator is not 0, then we get 0. Like if you think about it, 0 divided by 10. I have 0 cookies that I'm going to share with 10 people. You get nothing. If I have 0 and I divide it by 10, I don't know, it's got a lot more zeros. This is still, I have 0 cookies divided by a whole bunch of people, nobody gets anything, okay? And so as long as the numerator is 0, so if I have this x plus 1 equals 0, when x is equal to negative 1, this whole thing becomes 0. What that means is, in that equation we saw a second ago, y is equal to 1 over x, if I'm trying to find where does my y value equal 0, I have 0 equals 1 over x. Well, I'm just looking at the numerator. Can 0 ever equal 1? Well, if so, I will give you $0 million and you give me $1 million in return. 0 can't equal 1, so our y value can never equal 1. I lied. Our y value can never equal 0. And so that's why our range goes from negative infinity to 0. And then 0 to infinity. So we won't have an x value of 0 or a y value of 0. Okay, that's a good start for the parent functions. Hopefully that was a review of Algebra 2. If not, we're going to hit a lot of these in more detail as we keep going. All right, like, subscribe, comment, and go practice.